Now listen all of you. This is taken as plus q. This is minus q. And the dipole length is 2a. Dipole axis length is 2a. And the point P is at a distance r from the center of the dipole. If you take this is the center point, and then this distance is small r. This distance is small r. Okay, now listen. So the third case is electric potential at any point due to an electric dipole. So at any arbitrary point, suppose we are taking the point P here, and that point P is at a distance r from the center of a dipole, and the dipole is constituted by plus q and minus q charge, and the two charges are separated by 2a distance as usual. Okay, now we need to find out the potential at the point P due to plus q charge, that will be a positive potential, and potential due to minus q charge at the point P, that will be negative value, but they are not same because the distances are different, isn't it? Got it?
Yes.
Okay.
Yes, sir.
Now you have to complete the diagram. Again, complete the diagram. So what I am doing here, I am extending this point straight, and from the charge q minus q, I am dropping a normal towards this line 90 degree, and from plus q also I am dropping a line towards this at 90 degree. Okay, this is 90 degree. This also 90 degree. And the distance of the point P from minus q is this much. This yellow color is visible.
Yes, sir.
And here this much only. This is little lengthy derivation, and this is the point P, and we will take these points. The minus q is placed at a point A. Minus q is placed at a point A. The plus q is placed at a point B, and this normal drawn to the line, the point P, this is taken as N, and this normal is taken as M. The distance of the point P from the center of the dipole, means from center from here till this point, that is R. So the point P is at a distance R from the center of the dipole, means the black line is small r.
Yes, sir.
Okay. Now tell me the equation. Suppose we consider first the minus q charge. Then electric potential at the point P because of minus q charge will be what? V due to minus q.
Minus 1 by 4 pi epsilon naught.
Minus 1 by 4 pi epsilon naught into q by
the hypotenuse, sir.
We can write AP, correct?
AP, yes, sir. AP, the hypotenuse.
By AP, we'll write AP. And also the same way, the potential at the point P due to this plus q charge, which is placed at B,
Yes, sir.
that is V due to plus q charge. Potential due to plus q charge is equal to, it is plus 1 by 4 pi epsilon naught because it is positive charge, and q divided by what? BP, q by BP. Written?
Yes, sir.
Now the next line, the net potential at the point P because of plus q and minus q charge can be obtained by algebraic sum of electric potential due to plus q and minus q charge, isn't it?
Yes, sir.
Then write down the net potential at the point P, comma V is equal to net potential at the point P because the net potential at the point P due to the dipole, comma V is equal to V due to plus Q, V due to minus Q, and V due to plus Q. V due to minus Q, or we can write first positive, V due to plus Q plus V due to minus Q, potential due to plus Q and potential due to minus Q. V due to plus Q and plus V due to minus Q. You take this as equation number 1, this as equation number 2, this is equation number 3. Then substituting equations 1 and 2 in 3. Substituting equations 1 and 2. What will you get? V is equal to plus Q, it is 1 by 4 pi epsilon naught. We can take from these two equations Q by 4 pi epsilon naught common factor, isn't it?
Yes, sir.
We'll reduce one step. We'll take the common factor outside first when we add both equations. In both equation, Q by 4 pi epsilon naught is common factor, that is taken outside. Q by 4 pi epsilon naught. Then inside the bracket, for V plus Q it is 1 by Bp. 1 by Bp. Then plus become minus because potential due to minus Q is minus 1 by 4 pi epsilon naught Q by AP. So this negative become minus 1 by AP. Q by 4 pi epsilon naught is common, it's taken outside. Q by 4 pi epsilon naught is taken outside. So it become minus 1 by AP. This is equation number 4. In this last equation, that is Q by 4 pi epsilon 1 by Bp and 1 by AP. We don't know how much is 1 by Bp and 1 by AP. These two values are unknown. We have given only the charge minus Q magnitude plus Q magnitude, two-way distance, and also the distance R from the center. Okay. We don't know the value of this Bp or AP. Now if we take this angle, if the point P is, the line R is making an angle theta, if this angle is theta, this also will be theta, isn't it?
Yes, sir.
The opposite angle is theta. Now what we are going to do here, listen, normally we apply this equation for ideal dipoles. An ideal dipole means it is like a molecule of HCl. Okay. So if you take an ideal dipole, this two-way distance is very, very small. In that case, in such case, we can consider the distance BP. The distance BP, it will be almost equal to the distance NP. NP and BP will be same. Right now it is not looking like same, isn't it?
No, sir.
But it will be same, almost the same. There won't make much difference if it is an ideal dipole. Means if you bring these two charges very close to each other, like in the order of Armstrong, okay, inside a molecule, like in that case we can take this BP and NP are equal. So instead of BP we can substitute for NP. Got it? And for
Yes,
the
sir.
charge the charge minus Q at A, the distance AP, we can take instead of that what? MP. We can write AP is approximately equal to MP and BP is equal to what? NP. So we will find a new expression for BP as in terms of R, that is by using NP, and we'll find an expression for AP because it is approximately equal to MP. For that we have to do some process now.
Are they equal, sir? Because in a right triangle, hypotenuse is greater than one of the sides, right?
Now that only I told in the beginning. Right now it is not equal. Okay? And it is for explaining to you. But in practical situation, what is the situation? In practical case, these two charges are, normally we apply these equations for ideal dipole. An ideal dipole means like a molecule of HCl. its bond length is not 1 millimeter also. It is like 2.73, if my memory is correct. It is nearly 2.73 or 63 degree Armstrong. So this distance is only 2.63 degree Armstrong. In that case, if you take these two distances, this difference of this NP and BP will be negligible. Both of them we can take almost same. Got it?
Yes.
In this type of large figure, it is not same. Of course, it is not same. We can see from here. This angle is 90 degree and this is not 90 degree. So it cannot be equal. If these two angles are same, then they will be equal. Right now it is not equal, but we can take it approximately same, almost same, if it is an ideal dipole. So because in the ideal dipole, these 2 points A and B will be very close to each other. Got it?
Yes.
Now, write down. Next line. From the triangle AMP, sorry, the center of this point, the center of this center of the dipole will take O. This center of the dipole is taken as O, means middle of the 2A distance. We are taking this point as O. So from the triangle OMA, from the triangle OMA, the triangle OMA, what is cos theta is equal to? What is cos theta is equal to?
Opposite by adjacent.
Adjacent side by hypotenuse, isn't it?
Yes, sir.
Yes, sir.
Adjacent by hypotenuse, sorry, yes.
What is adjacent side?
Yes.
OM.
AM. OM.
This is theta. This is theta. So adjacent side is this one. OM.
Oh,
OM divided by hypotenuse is what?
Hypotenuse is AO.
no, it's A, right?
AO.
Half 2A.
Hypotenuse is AO or OA. That is half of the dipole axis, isn't it?
A.
So we can write small a. This is half of the dipole axis. So OM we can write what? This OM is equal to A cos theta.
A cos theta.
OM is equal to A cos theta. Okay. Then I can also write from here. You see, in an ideal dipole, AP and MP are almost same, approximately same. So we can write next line. For an ideal dipole, AP, the distance from A to P, is approximately equal to MP. That is AP is equal to what is actually MP? From the center, from here till this point is P. That is OP plus OM. Correct?
Yes, sir.
OP plus OM. If we add from O to P, that is R, and O to M, that is what? OM, we have A cos theta. So AP equal to what?
A cos theta into R.
R plus A cos theta. OP is R. OP
Yeah, okay.
R plus A cos theta. So AP is equal to R plus A cos theta. Means from the point middle of the dipole to the point P, this distance is R, plus this OM is, from this triangle we got OM is A cos theta. So R plus A cos theta is AP. Now similarly, BP, this distance B to P, it is approximately equal to NP. For an ideal dipole, it can be almost equal to NP. So BP is approximately equal to NP. But NP equal to what?
BP will be equal to OP, right?
No.
NP, NP.
How to OP? OP is very different.
Oh, sir, NP, yes, sir, sorry.
NPM. So BP is approximately equal to NP, and NP equal to what? NP is OP minus ON.
R by 2. R by 2.
No.
NP is equal to OP. From this total OP, we have to subtract ON. OP minus ON, correct?
Yes.
From the triangle, this triangle, ONB, from ONB triangle, what is cos theta? From the triangle ON,
Cos theta is ON.
1 by
ONB, from the triangle ONB, cos theta is equal to
ON by A.
adjacent side by hypotenuse. Adjacent side is ON, hypotenuse is this A, half of the dipole length. So ON divided by A. So what is ON equal to?
A cos.
A cos theta. ON equal to A cos theta. Then we can write NP equal to what? In this equation, OP is R and NP is ON is A cos theta. So we want NP. NP will be equal to this total R minus this is A cos theta. Okay. So we can write NP is equal to NP and BP are equal, isn't it?
Yes, sir.
Okay. So NP is equal to, so instead of NP we'll write BP because both are same. BP is equal to, because NP and BP are approximately same, BP is equal to the total R minus A cos theta. R minus A cos theta. Got it?
Yes, sir.
These equations, that is AP equal to R plus A cos theta, you take it is 5, equation 5th equation. And this equation BP equal to R minus A cos theta is the 6th one. Equation number 6. Substitute equation 5 and 6 in equation number 4. Instead of BP we'll put R minus A cos theta, this one R minus A cos theta. Instead of AP we'll write this one, equation number 5, R plus A cos theta. Substitute for AP and BP, then write down substituting equations 5 and 6. Equations 5, 5th one and 6th one in equation 4, in 4th equation. We can get the net potential V is equal to 1 by Q by 4 pi epsilon naught, common factor, then in bracket 1 by BP. So for BP we can substitute what? 1 by R minus A
cos
theta in bracket. Then we have minus 1 by AP, that is minus 1 by in bracket R plus A cos theta. V is equal to, potential V is equal to Q by 4 pi epsilon naught, Q by 4 pi epsilon naught. Denominator what we can take as LCM? What will be LCM? Can take A plus B into A minus B, A square minus B square, isn't it?
R square minus A square cos square.
And numerator we can cross multiply. So when we multiply numerator cross this way, means this will be R plus A 1 into R plus A cos theta. So means R plus A cos theta.
Minus R
In bracket minus, then R minus A cos theta. This bracket is compulsory because there is a minus sign. And denominator we can take R plus A cos theta into R minus A cos theta. What happened to the numerator part?
Sir, R gets cancelled.
Yeah. On the
So
numerator
2A
side,
positive.
this plus r minus r cancel, and this minus into minus become plus 2a cos theta will come. R and r cancel. Cos theta plus a cos theta minus into minus plus a cos theta plus 2a cos theta. And denominator we can write a square minus b square from a plus b into a minus b. So r square plus a square cos square theta. A plus b into a minus b, a square minus b square. So r square minus a square cos square theta means the final equation become v is equal to electric potential at the point, net potential V is equal to Q by 4 pi epsilon naught, Q by 4 pi epsilon naught. Numerator is 2a cos theta, a cos theta plus a cos theta, 2a cos theta. R is cancelled and divided by denominator is a plus b into a minus b, a square minus b square. So we can write r square minus a square cos square theta. R square minus a square cos square theta. A square cos square theta.
Q into 2 is P.
Very good. So the again equation,
P cos theta.
we have Q into 2a is dipole moment.
Yes, sir.
Q into 2a is equal to P. So we will get this Q into 2a, we can substitute P. So 1 by 4 pi epsilon naught P cos theta. The final equation is, that is the final equation, the potential at any point V is equal to, this I am taking 1 by 4 pi epsilon naught, Q into 2a is P. So 1 by 4 pi epsilon naught, the standard format. Then Q into 2a is P cos theta, P cos theta, divided by r square minus a square cos square theta, r square minus a square cos square theta. Okay.
Yes, sir.
Now, for an ideal dipole, what we can write? If A is very less than R,
So it can be neglected.
so this A square becomes still smaller, means A square cos square theta we can neglect. So write down, for an ideal dipole, A very less than R, then potential V will be equal to, V is equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, P cos theta by
R square minus cos theta.
no,
Cos square theta.
that is cancelled.
No, that's cancelled.
Oh, yes.
That is neglected. A is very small, then A square will be still smaller. So P
Yes, sir.
cos theta divided by R square. R is the distance. Now all these values are given. Okay, theta, the angle of the point P, the angle subtended by the point P from the center of the dipole will be given R square. This is the final equation for electric field intensity at any point because of a dipole. Sorry, electric potential. The final equation for electric potential at any point due to a dipole.
Okay, sir.
So among the derivations of potential due to dipole, this is the important one, and because this can be applied in any case. Before we derived for axial line, isn't it?
Yes, sir.
So this final equation, that is potential at any point due to a dipole, is 1 by 4 pi epsilon naught P cos theta by R square, where P is the dipole moment, theta is the angle subtended by the line joining the point P to the center of the dipole axis. R is the distance of the point P from the center of the dipole. Okay, so when we go to the dipole, the diagram, now the final equation we obtain for electric potential, the final equation for electric potential at that point P. At this point P, electric potential is given by V is equal to 1 by 4 pi epsilon naught. For an ideal dipole, it is P cos theta. P cos theta divided by,
R square.
what is the next one?
R square.
A square minus a cos square theta we neglected. Divided by
R square.
divided by R square. P cos theta by R square. If you take a point on the axial line, means this way, theta is 0, here theta is 0, so cos 0 is 1, equation become 1 by 4 pi epsilon naught P by R square. Now if I take the point on the equatorial line, if the point P is moved from here, in this equatorial line, now what is theta? From the axis of the dipole, if you take point here, what is theta?
90.
90. Then if you put cos theta here, theta 90 degree. Cos
Zero.
90, 0. V equal to 0. Got it? This equation can be applied on equatorial line. On equatorial line, theta will be 90 degree. Cos 90 will be 0. Potential will be 0. If you take the point on the axial line, then theta becomes 0. This theta becomes 0. Cos 0 is 1. So 1 by 4 pi epsilon P by R square. Means this is a general equation. It can be applied for any point. This point P, or a point on the axial line, or a point on the equatorial line, everywhere it can be applied. Okay? So these are the three different cases of potential due to a dipole. We'll stop here and we'll continue next class. Okay? Thank you.
Thank you, sir.